Thanks for coming back, picking up where we left off. If you turn it over, we have 4 new functions that we want to graph. Notice that the value a here in this first and second example are all numbers that are less than 1, whereas the previous 4 were all values, the base were all values that were greater than 1. So what effect does that play on the graph? And even more than that, okay, look at the second example here and how the exponent now is the opposite of x. What effect does that have on the graph? These last two right here, 5/4, just a fraction, but that value is greater than 1. This graph should behave like the previous 4 did. All right, this base right here is also 1 1/4, but how does the graph behave when you have a negative x? Well, we're going to plot points and learn what happens. Okay, so our function is 1/4 to the x. Again, it must be something to do with the table, the way it's jumping around. I guess it's jumping around for you guys too. All right, so what's 1/4 raised to the -2 power? All right, so we need to revisit that. Well, what happens is we want to make that exponent positive. And since we already have a fraction here, I really don't want to move this to the denominator again. I could, okay, but what we want to do is we want to make -2 +2, so we can square the top and bottom of our fraction. Well, if I'm going to go from a negative exponent to a positive exponent, then that means I have to reciprocate what's inside. I have to reciprocate the base, so that just becomes 4 squared. 4 squared is 16. I want a positive exponent. Since this is already a fraction, I don't want to move it to the denominator. So let's make the exponent positive, but in doing so we also have to reciprocate the 1/4 and make it 4. Already notice that these y values are decreasing. All right, 1/4 to the 0, anything to the 0 power is 1. 1/4 to the first power is just itself, 1/4. And 1/4 squared is square the top, you get 1, square the 4 in the bottom, you get 16. So this is very small. So the progression of the y values is that they're getting smaller as you move from left to right. So I would think that these graphs are going to be, or at least this one's going to be decreasing. Okay. At least label one of your tick marks so we know what the increments are. So that's -1. All right, I'm studying these y values. The greatest y value is 16, so I think for this I'm going to count by 4s. So label that 4, so that suggests that this is 8, 12, and 16. You don't have to label all of them, but at least one so that we know what the increments are. All right, let's plot -2, 16. So -2, 16 would be way up here. Next point is -1, 4. In the middle of the table we have 0, 1. So that'd probably be about right here. At +1 and +2, I'm getting really close to the positive x-axis. It's going to be hard to graph 1/16, but it's way down there. So connect the points. Notice that I'm decreasing. It's really hard with this pen. Okay, but I'll never touch the positive x-axis. It is our horizontal asymptote at y = 0. All right, so the pattern we should see is, or at least an observation that we should see, is that when the base is a number between 0 and 1, and we have a positive exponent, the graph is decreasing. All right, so what happens here? All right. Well, let's make x a positive x. It's currently a negative x, so let's make it a positive x. By doing so, we're going to reciprocate, and we're going to get 4 to the x. So this is now going to look like the previous examples because our base is a number greater than 1. All right, let's come down here and fill in the table and then plot the points. So the original problem was 1/4. Let me put it right here. So 1/4 raised to the opposite of my x value, so opposite of that would be squared. So that's going to be 1/16. Okay, the exponent in the equation is -x, so we're going to make a -1 +1, so this is just 1/4. So my y values are increasing. Anything to the 0 power is 1. Now I'm going to insert a 1 for x. Well, that's going to make it negative 1. I want to make that exponent positive, but in doing so, let's reciprocate. So that's just going to be 4. Put in 2 for x, so it's going to be negative 2. Make the exponent positive 2, reciprocate, 4 squared is 16. So notice these y values in the table are increasing. So I'm going to return to an increasing exponential function. Again, I'm going to count by 4s. Label one of the tick marks. You don't have to label all of them. At negative 2 1/16, I'm real close to the negative x-axis. I am increasing, but slowly. 0, 1 is a point, 1, 4, and 2, 16. Connecting, but not touching the negative x-axis, going through 0, 1, and increasing. When we start to look at application problems, we're going to consider this a decay. If the graph is decreasing, we have decay. And here, if the y values are increasing, we're going to consider this a exponential that grows, or a growth situation. Just like the previous 4 on the other page, those were all growth, exponential growth functions. Okay. All right, so we're going to kind of look at what's happening here. I encourage you guys to do these on your own, fill in the table, and then plot the points. So why don't you pause the video, complete the tables, okay, thinking about what we did in the previous 2 examples, complete the graphs, and when you've done that, do a self check, then turn the video back on. All right, so ta-da, there it is. Now that you're seeing it and it's visible, you might want to stop the video again and just check your work. All right, some observations about the graphs that we have, these last 2. Okay, first of all, notice the scaling. I went by 1s along the y-axis, as determined by the values in the table. All right, and notice that they're not growing very quickly right here between negative 2 and 2. It takes a while for the growth to kind of start happening, but of course down here at the end, the further out you go along the positive x-axis, the graph will start to rise quickly later. It just takes a little bit longer for it to rise quickly. All right, so we have another growth situation here. The y values were increasing, and another decay situation here. Again, the reason this one is growing is because the base is a number greater than 1. 5/4 is 1.25 with a positive exponent. The reason this one is decaying is because if you were to make x positive, then you'd have to reciprocate, and the value of 4/5 is less than 1. They both have the same asymptote, and that is the horizontal asymptote y = 0. All right, so we're going to use these observations to answer some of the questions that we need to on exponential functions. So let's complete the bottom part of this worksheet. All right, so the directions for this, and a group of your problems on your homework asks you to describe the transformations on f that gives you the graph of g, and then to sketch both f and g by hand. All right, so let's look at example 1. Something that's obvious pretty much right away that stands out at us is that we didn't deal with the situation where we had a negative in front of our a value. Remember, the description of an exponential function is that the base is always positive. Well, the negative doesn't go with 6, else it would be in parentheses. The negative one just acts as a multiplier on 6 to the x. So 6 is still the base and it's positive, so that's okay. We're just multiplying our answers by a negative 1. So consider this your new parent function, so to speak, and then what are the transformations over here? Okay, well, based on our past experience, we know that we're going to take whatever graph this is and move it up 3. But we also need to address the situation of what does the negative do on these graphs? Well, if you think about it, you're going to multiply negative 1 by all these answers. All these answers will be positive, but when you multiply by the negative 1, they're all going to become negative. So when the y's change from positive to negative, we're going from quadrant 1 or 2 down to quadrant 3 and 4, because that's where your y's are negative. So you might want to just make yourself a note over here and say, hey, this is a reflection. That multiplier of negative 1 is a reflection through the x-axis. So let's record that over here. We're going to reflect through the x-axis. When we have that multiplier in front of our exponential function. I'm going to try and squeeze both graphs in on the same grid over here. Alright, so based on our prior experience, let's just ignore the negative for a minute and consider what does 6 to the x look like. I'm just going to graph 6 to the x. Well, I know if x is 0, anything to the 0 power is 1, so like the other functions, if I called that point 0, 1, I know my graph 6 raised to the x is going to go through here. And it's going to have this basic shape right here. So I'm not even graphing f. I'm graphing just another function, 6 to the x. Okay, and of course this is going to extend outward, and it's never going to touch the negative x-axis. It'll only travel a little less than 1 between this point and this point right here. Alright, so maybe in a different color, I'm now going to graph f. Well, if I were to reflect, change all y values on this graph to their opposites, well, 0, 1 is going to plot as 0, negative 1, take the opposite of y, this is the y coordinate, and draw its reflection. So I'm going to have to like come off this graph, and then I'm trying to draw the reflection through the x-axis. So I'll call this my f graph. Alright, so now let's look at g. The only difference is that I need to now move g up 3 off my red graph. So if this is negative 1, I'm going to count up 3 points. So take this kind of key point and move it up 3 points and then draw the graph off that key point. So if that's negative 1, I'm going to move up 1, up 2, and then this is going to be 2. So I've just moved up vertically 3. This is my new key point. Alright, well, I'm going to have to travel upward as I move to the left, but remember, okay, if I mark this as 3, I'm never going to get up to 3. I'll never pass 3 because this vertical distance between this point and the asymptote is 1. Alright, so I'm trying to maintain the graph of the red graph, and I'll call this G. So we described the transformations over here, up 3, that yields the graph, and then we sketched both by hand. We had to actually draw an extra graph to get us started. Let's look at example 2. Alright, if this is my parent function, then my transformations to my parent function would be move right 2, because my minus 2 is with my x. So I'm going to take a key point and move it right 2 and down 3. Alright, well, what is the basic shape of 4/10 less than 1 to the x? Well, we know that's a decay situation. We know that graph, if x is 0, passes through 0, 1. Anything to the 0 power is 1. And it's going to have to decay. So I'm just going to draw its basic shape like this, decreasing. I'm going to label it f. And then I'm going to take this key point right here, and I'm going to move this key point right 2 and down 3. I might go actually down 3 and then right 2. So I'm already here at 1. If I move down 1, 2, 3, label this negative 2. That key point shifts down to here. And then I want to draw the graph. Oh, and sorry, then I want to go, I went down 3, now I want to go right 2. Let me do that first. I don't want to do two different graphs. So this key point now, down 3, right 2, this key point now is going to be moved over here. So let me take care of that point right there real quick. Okay, so that's better. Yeah, I didn't want to draw two graphs. So down 3, right 2. And so off of this key point, which corresponds to this key point right here, I'm going to extend my graph downward, but it'll never reach negative 3. So think of that as your horizontal asymptote now. And then just trying to draw the graph to the left off of it. So this is G. Alright, so if we were to identify the asymptotes, it didn't ask us to, but in another question it will. If we were to identify the asymptotes, this one has an asymptote of y equals negative 3 because of the shift down. This one right here is going to have a horizontal asymptote of y equals 3 because of the shift up. So something to be mindful of even though it's not requested. Okay, I actually should put that y equals 3 right here since I need to graph this one right here. All right, so let's take a look at our third example. I think there's a 3 on our handout. I don't know where it went to. Okay, we're going to graph this function, which is again a decay. That was one of the ones we graphed previously, I think. So 0, 1, and it decays. Ooh, don't ever touch the positive x-axis. Okay, now study these transformations right here. I know we're going to move it up 2, but look at this change in the exponent. You have to really look carefully. We have to change. We're going to change this exponent from positive x to negative x. Well, that's not going to be a reflection through the x-axis. It's actually going to be a reflection through the y-axis. So when the negative is on the exponent, okay, we're going to reflect it through the y-axis. Flip it over the vertical. So compare and contrast this reflection with the previous reflection. Okay, you just have to notice where the negative signs are. This negative's out front, in front of the whole exponential. So it's going to be a horizontal reflection, whereas this is a vertical. And if you think about that, come back up here, because you can make another connection. Compare the first 2 graphs here that we did. When the exponent changes from positive to negative, okay, you can see how the graphs, trying to get back up there, think about reflecting through the y-axis, flipping it over, so this decay is going to become a growth. Just like over here, when you change the exponent signs, okay, if I were to reflect through the vertical, this growth would become a decay. Okay, so that's an observation that we can take away from it. Okay, so let's look at example 3. So I need to do a reflection through the y and then shift it up 2. All right, if you want to take 2 steps to do that, that's fine. You can show the reflection through the y and then up 2. Or if you want to just take 1, that's fine. Move it up 2. So this point now is 0, 3. But it has to be an increasing situation now. So it's going to go up. And then as it decreases here, notice that it's never going to fall below y equals 2. So if you were asked what's the asymptote, you would have to say it's y equals 2 because of the shift up 2. All right, I know we're kind of getting up there in time. It's about 18 minutes, but we only have 2 left. Let me see if I can get these 2 in so that we don't have to do another video. Okay. All right, down here at the bottom, given the following, use a graphing utility to construct a table of values for the function. Okay, got it. Then sketch the graph, identify any asymptotes. Sounds good. So let's come over here and build our own table, unlike the previous examples I gave you. Yeah, I got to fix that. Okay, we're just going to build our own table. Or I guess it's a little bit better. All right, and we're also going to build a table over here. Let's see. I think my hand's getting unsteady. It's been a while since we've been recording. All right, so let's fill in our own table. Well, I guess some good values would be a couple of negatives, 0, and 1 and 2, like our other tables. All right, so given the following, use a graphing utility to construct a table of values for the function. So go to your calculator, type this into y1, then hit second graph, which takes you over to the table, locate these x values, and then fill in the y's that go with them. Okay, so I'll give you guys a moment to do that. Do it for both 1 and 2. Then type this function in to y equals, go to the table, and fill in the values that belong over here. And actually, I think I'm going to take it out to 4 or 5 decimals when I fill in the y values here. Not that I need them for graphing, but I think you're going to see when you go to the tables that you need to go to 4 or 5 decimals. All right, so pause the video, fill these in, and then turn it back on. All right, hoping that your y values kind of compare to what I have here. Let's talk about the table at x equals 0 real quick. Why is my answer not 1? I thought we said earlier that when anything is to the 0 power, we're at 1. Well, this wouldn't be to the 0 power, actually, because it's not just x, it's x minus 2. Likewise, we don't have just x here making this 1. We have x minus 5. Something worth talking about, I think. All right, by this time you might have went ahead and graphed it on your calculator. Okay, but otherwise, if you're going to sketch a graph by hand, if you don't have a calculator, we want to pay attention to the y values in the table, and that determines the scaling on our y-axis. Okay, all these y values right here are very close together. So I go as high as 2, so I guess that suggests that I'm going to have to at least go up to 2 here. Alright, so now that we have this set up, let's go ahead and plot. -2, 1.0123. Wow, right here. -1, 1.037. At 0, I'm at 1.1 repeating, and at 1, I'm at 1 1/3. Finally, I can start to move up a little bit, and at 2, I'm at 2. Right? So I'm going to try and connect these. Oh my goodness. That's not horizontal. Oh, missed that point. It is going to grow, and as x goes to infinity, this graph would turn upward. I do have an arrow here. When I talk about the horizontal asymptote, notice that these y values right here, even though they're getting small, as you go up in the table, if I had -3, I would never be less than 1. And you can scroll. You got your table there in front of you on the calculator. Okay, so we do have a horizontal asymptote. It just happens to be y = 1. And think about that shift up. So I'm going to put the asymptote right up here. It is going to be y = 1. Alright, likewise, let's graph this one as well. So if you want to pause the video and then turn it back on after you've sketched it. Okay, this graph is pretty flat for a long time. I mean, it's not flat. It is increasing. It's just really slow at increasing. Okay, let's observe what we have over here. If I had -3 in my table, okay, you can look on your table in your graphing calculator. This value will never get to 2. The calculator might look like it does, but it doesn't. Okay, the calculator has limitations. So it looks like I have a horizontal asymptote at y = 2. Look back at the equation to make sure and confirm, and yep, that makes sense because of the shift here. So we have a horizontal asymptote of y = 2. Okay, alrighty, so hopefully you have a good understanding of how to sketch exponential functions.